Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so in this video, I will explain to all of you about Chapter 4, Enterprise Modeling, where Enterprise Modeling is in Phase 2 of SDLC, that is in System Analysis Phase. Chapter 4 basically will cover 4 subtopics. Those are overview of data and process modeling, data flow diagram DFD, data dictionary, and also the process description tool. However, in this video, I only will discuss about the first 2 chapters. Those are overview of data and process modeling and also the data flow diagram DFD. Okay, in the previous chapter, we have discussed about the requirement modeling. Okay, so in requirement modeling, we have done the fact finding through the interviews, investigation, and so on. Okay. So basically, the fact finding have investigate the current system and also identify the user's requirement. Alright. So in this chapter, we are going to use all of the data and also all of the information that we have gathered in the fact finding process, okay, in the previous chapter, to develop a logical model to the proposed system. So, what is logical model? Okay, so logical model is basically shows what the system must do. Okay, so in logical model, okay, we only design about what the system have to do. Okay, regardless of how are we going to implement or how are we going to solve the problem lah. We just design the logical model based on the requirement during the fact finding. So later on, after the logical model is finished, then the physical model is developed. Okay, so physical model describe how the system's requirement are implemented. Alright, so basically the physical model is a design of how the system will be built. For example, we build a pseudocode, okay, to solve a certain problem, okay, a certain problem or to solve a certain process in the logical model. In developing a system, okay, system analysts use many graphical techniques to describe an information system. One of the most popular method is to use DFD or data flow diagram. So what data flow diagram or DFD does? Okay, so it shows how the system transform input data into useful information, or we can say that DFD shows how the system will transform the input into a useful output, okay, through several processes. So it is basically shows how the data moves, okay, through an information system, okay, but it does not show how it is processed. Okay, for example, the DFD shows that how many data is needed to calculate a CGPA. Alright, but it only shows what data is needed to calculate CGPA and what are the output, or what is the output, that is CGPA lah. But the DFD will not show how the CGPA will be calculated. Alright, so the CGPA, the method or the process of CGPA is being calculated will be shown in the physical model. So DFD use 4 basic symbols that represent the process, the data flows, the data stores, and also the entities. And there are 2 types of symbol set in creating the DFD. The first one is Gain and Sarsen symbol set, and the second one is the Jordan symbol set. So the symbol sets are the reference of the process, data flow, data store, and also the entities, and it must use capital letters for the label. Okay, so these are the symbols that are used in gain and Sarsen symbols and also the Jordan symbols. So for your information, we are going to apply only gain and Sarsen symbols. Okay, so you just have to know and you just have to recognize the Jordan symbols, but we are going to use the gain and Sarsen symbols. So the first symbols in both gain and Sarsen and also the Jordan symbol are the process symbol. Okay, so the process in gain and Sarsen is illustrated by using the boxes. Okay, and Jordan symbols is illustrated by using the oval shape. The second symbol is the data flow. Okay, data flow is illustrated by using the line together with the arrow. Okay, and then the third one is data store. Okay, the gain and Sarsen use the rectangle box with one line in the box. Okay, where the Jordan symbols use the rectangle with no left and the right lines. And the last symbol is the external entity symbol. Okay, the gain and Sarsen use shadow, okay, behind the rectangle, while the Jordan symbol has no shadow behind the external entity symbol. Okay, let's elaborate the first symbol in creating the DFD. Okay, so the first symbol in the DFD is the process. So process is where it receives the input data and produce output. Okay, so basically the process must receive a data, okay, receive at least one data and produce at least one output. So the process, it is said here, the process contains the business logic and also the business rule, or what are the tasks that must be done by the system. Okay, so it is referred as a black box. Okay, so it must have input and output, and also the general function of the process are known, but the underlying details and the logic of the process are hidden, meaning that we only mention the main process. Okay, for example, login process. So the process of login, okay, where we have to match the login ID and also the password in the database, let's say, okay, the process of matching the ID and also the password is hidden. Okay, but we just mention in the process name login process. And if the system analyst wish to show the additional level of the detail or wish to show all of the detailed process, okay, he or she can zoom in on a process symbol and create a more depth of DFD, meaning that you will have to create a second version of DFD, okay, just for that one particular process. For process symbol, the name of the process appears inside the rectangle. Okay, so the process name identifies a specific function and consists of a verb. Okay, and if necessary, you can put an adjective with the verb. Okay, for example, calculate commission. Okay, calculate commission. Calculate final grade, verify order, fill order. So all of that phrase are the phrasal verb. Okay, meaning that you use verb to represent the process name. Okay, so and you must remember something, all of these name must be written in capital letter. Okay, so all of the name in the DFD must be written in capital letter. That it does apply to all of symbol. Okay, process symbol, data flow symbol, data store symbol, all of the symbols must be, all of the symbols name must be written in capital letter. The second symbol is the data flow. So a data flow is a path for data to move from one part of the information system to another part. Okay, so data flow represent one or more data items. So you can draw more than one data flow, okay, for a particular process. And the symbol for a data flow is a line with a single or double arrowhead. And please be reminded that there are 3 types of data flow and process combination that must be avoided. Okay, the first kind of combination is the spontaneous generation, where a process that produces an output but has no input. Okay, you cannot design a DFD with a process but there is no input at all in that particular process. Okay, as I said before, one process must at least has one input and one output. The second combination that you cannot do is the black hole combination. The black hole combination is the situation where the process that receive input but have no output. Okay, the process receive input but the process not producing the output. Okay, so it is called a black hole. And the last combination is the gray hole. The gray hole is the situation where the input is insufficient to produce an output. Okay, for example, we give input. Okay, we give input, for example, birth date. Okay, we give input birth date and the output is calculating the CGPA, for example. So we cannot produce CGPA based on birth date. Okay, so it is called a gray hole where the input is insufficient or the input is an error lah. Okay, the input is not suitable for producing that particular output. Okay, so the data flow name appears above, below or alongside the lines. Okay, so you can place the name whether above the line or below the line or alongside the line. Okay, so a data flow name consists of a singular noun and an adjective. Okay, so it must be written in singular noun. Okay, with no S lah. Okay, singular maknanya kata nama yang satu sahaja. Okay, and it is added with adjective, it is needed. Okay, for example, data flow, the data flow for deposit, okay, for invoice, payment, or we also can give the name of daily payment, student grade. Okay, so those names are together with the adjective. Okay, whose grade? The student's grade. Okay, what kind of payment? Daily payment. Okay, so you can give name for data flow. Okay, you must remember it must be in a singular noun. Okay, noun only. You cannot put verb in the data flow. For example, calculate gross pay, for example. So you cannot put the word of verb. Okay, you cannot put verb in data flow name. Okay, you must put singular name. Alright. Okay, this is the example of correct, okay, with no error DFD. Okay, so the first example, service, the data, the input data is the services performed. Okay, and then the process is to create invoice and the output is the invoice. Okay, so meaning that here the input is all the data or all the particulars about the services or the product information. Okay, and then we can create invoice from the product information and then the output is the invoice lah. Okay, so in this example, in this first example, there is only one input and also there is only one output. Okay, so take a look on the second example. Okay, there is only one input that is submitted work. Okay, so the process is grade student work and the output is the graded work and also the student grade. Okay, where this situation is also possible. Okay, you only, for example, in your situation, you just submit your work and then your work or your task will be graded by your lecturer. So the output is the graded work, and also your lecturer can give you a grade, whether you get A, you get B, or you get C. So here in this situation, the process of grade student work, okay, can produce two type of output from one input. Okay, from one input that is submitted work, okay, the lecturer can produce two types of output by using the process of grade student work. In the third example, okay, this third example shows you two inputs with one output. Okay, so the example here shows the hours worked and also the pay rate. Okay, and then the process is to calculate the gross pay. Then after the calculation, the output is the gross pay. Okay, so hours work is how many hours that a person work lah. Okay, dia bekerja berapa banyak masa, and then how much is the pay rate. Okay, for example, junior technician, okay, mungkin rate dia lebih rendah compared to the senior technician, for example. Okay, so mereka ada rate yang berbeza-beza. So let's say the junior got RM5 per hour, and then the senior got RM15 per hour. Okay, for example. So of course lah dia akan dapat pengiraan yang berbeza-beza, but the gross pay or the output is only the gross pay. Okay, and the last example is where you give input to one output, to one process, and then the process produce one output, and the output will be input to the another process. Okay, examples here, the data about order will be input for the verified order, and then after the order is verified, okay, the output is the accepted order. And then the accepted order will be input for the assemble order, and after it is processed in the assemble order, the assemble order or the accepted order is changed into the inventory change. Okay, here are the incorrect examples of developing a DFD. Okay, so the first one is there is no input for the process. Okay, apply insurance premium process has no input. It only contains two output. Those are the policy number and also the payment amount. So this situation is known as the spontaneous generation. The second incorrect DFD is the black hole. Okay, where there is no output. Okay, but it only has two input here. Okay, hours worked and also the pay rate, and the process is to calculate the gross pay, but there is no output from the calculation. Okay, so this situation is known as the black hole, while the last situation is the grey hole. In the grey hole situation, okay, there is no sufficient input to produce a particular output. So in this example, the input is date of birth. Okay, so the process is to calculate the grade, and the output is the final grade. So as I said before, the date of birth is not sufficient or not suitable to calculate the final grade of a student. In this picture, please look at a data flow symbol as well. Okay, so as you can see in the picture, the data flow is a line together with the arrowhead. And the data flow normally represents one or more data items. The data flow could consist of a single data item, for example, for policy number, hours worked, okay, date of birth, or it could include a set of data. Okay, a set of data, for example, a class information, where the class information can contain the student IDs, the student names, the student registration dates, and so on. Okay, so the data flow can also represent a group of data instead of one data. Okay, let's move to the third symbol, that is data store. Okay, so the data store is used in a DFD to represent the data that the system stores. Okay, data that the system stores in the database lah. Okay, because one or more process need to use data in a later time. Okay, sometimes the data is needed from the stored data or the processed data, not from the user or the outside data. In DFD, the data store does not show the detailed content of the data store. Okay, because the detailed content is shown in the ERD, Entity Relationship Diagram. So now, in the DFD, we only shows the general data that we need to store in the data store. Okay, so that is why it says here the physical characteristic of a data store are unimportant because you are concerned only with the logical model. Okay, so it is unimportant now. Okay, when you design the database, it is very important, and when you are designing or you are listing the data dictionary, then it is very important. So the look of a data store in Gain and Sarsen is a flat rectangle that is open on the right side and closed on the left side. These are the several examples for the usage of data store. Okay, the correct usage of data store. So in general, a data store must be connected to a process with a data flow. In creating the DFD together with the data store, you have to remember something. That is the aim of storing the data in data store. Okay, so the aim is to use the data that is stored in the data store in the future. So, the data store must have at least one incoming data and one outgoing data. The name of data store, okay, appears between the lines that identifies the data it contains. So you have to choose a name that represents the data that you store in the data store. For example, the daily payments. Okay, so daily payments, when we read daily payments, account receivable, and also the patients, we understand that the data that is kept in the daily payments is all of the payment in daily basis. Okay, when we read the patient's data store, so we understand, we know already that the data that is stored in the data store is all of the data about the patients. And the data store name must be plural. Okay, it is a plural noun. Okay, as you can see in daily payments, okay, it says daily payments, patients, accounts receivable. Okay, all of the noun here are in plural form. Okay, it is not said as patient. Okay, so it is spelled with S. So meaning that it is a plural noun. And sometimes you have to add some adjective, okay, to show what are the exact data that is stored in the data store. For example, daily payment. So the noun is payment. Okay, what is to be stored in the data store? It is payment. So what kind of payment? It is a daily payment. So daily is the adjective and payment is the noun. Okay, so sometimes we have to put some adjective to the data store name. So in these examples, it is the correct example of creating the DFD with data store. Okay, so it is correct because as you can see in the data store, all of the data store have at least one input and one output. Okay, so for example, for daily payment, the data store get the data from post-payment process, and the data that is stored in the daily payment is the input for prepare deposit process. Okay, so in this example, it shows the incorrect way to use the data store. Okay, so the first example, okay, let us see on the first example, course and students data store. Okay, why it is incorrect? Because the data that is produced from one data store is the input to another data store. So this is the wrong way. Okay, it cannot happen. Okay, the data from data store must go through to at least one process before it goes into another data store. Okay, so here from one data store courses, okay, it goes straight away to another data store without any process. So in order to move from one data store to another data store, it must be through to at least one process. And for the second and the third examples, okay, post-payment and book flight examples, okay, both of the examples has lack either an ongoing or incoming data flow, meaning that the data is not sufficient to be stored in the data store. Okay, let's say customer payment is not sufficient to be stored, okay, in daily payment data store. And also the passengers data is not sufficient to give information or to give data to the book flight process. And the last symbol in DFD is entity. Okay, so entity represents a person, a place, a thing or event for which data is collected and maintained. Okay, so it also can be an external system. Okay, for example, the data is collected from the data that is needed in one system is collected from another system. Okay, so that another system is also can be represented in the entity. Okay, so the symbol of entity is a rectangle which may be shaded to make it look three-dimensional. Okay, so it is a rectangle with shade. Okay, so entity is also called a terminator. Okay, it means that the data origin or the final destination. Okay, so it is called a terminator because sometimes it is not sometimes lah. Okay, it is the data come from. Okay, it is where the data come from, and it also where the data or the information goes to. Alright, so it is called a terminator or data origin or final destination or also the external entity. So the source entity is the entity that supplies data to the system lah. Okay, that is the data origin entity. And the sink, okay, sink is the received data from the system or the final destination of the entity. So same as the others symbol, the entity's name must be written in capital letter and it is placed in the rectangle, in the box. Okay, so it must be a capital letter, it must be a noun, and it is placed in the rectangle. Okay, so these are the examples of correct use of external entity. Okay, for example, customer give payment details or payment data to the apply payment process. Or the last one, okay, the verify, the create paycheck process give data to the employee, external entity, and employee give time card data to the verified time card process. Okay, so these are all the correct process with external entity lah. Okay, as you can see also in customer and verify order, okay, there is two ways data flow. Okay, the first data is customer give order details or the order data to verify order, and then once the order is verified, okay, so the verify order process will give the invoice data to the customer. Okay. Alright, so in this slide, it shows the incorrect way to use the external entity symbols. Okay, so here it shows one entity symbol is connected directly to another entity. So this situation cannot exist. Okay, it is wrong, it is incorrect. Okay, so one entity must be connected to another entity through a process. Okay, so one entity can be connected to another entity through a process. Okay, so the second situation is one entity is connected directly to the data store. So this is also cannot be done. Okay, so this one, okay, the second, okay, customer and account receivable example, and also bank and daily payment example is the incorrect way, because the external entity is connected directly to the data store. Okay, as in the first example, okay, the right way is the customer and also the bank must be connected to the one process. Okay, must be connected to at least one process, then it can be connected to the data store. All right. Okay, so in this picture, okay, you can see the correct and also the incorrect example of data flow. Okay, so you can do process to process. Okay, you can also do process to external entity, and you are also allowed to do process to data store. But external entity to external entity is not allowed. External entity to data store is also not allowed, and data store to data store is not allowed. So please remember this. Okay, please do only the allowed or the correct way of connecting the process, the external entity, and also the data store in creating the DFD. So in this slide pun samalah, benda dia nak cakap pun benda yang sama. Okay, you are allowed to do process to another process, process to external entity, process to data store. And you are not allowed to do entity to entity, entity to data store, and also data store to another data store. Okay, now it is time for us to discuss how to draw a set of DFD. Okay, so basically the DFD is created based on your fact finding result. So meaning that if your fact finding is not sufficient, the information in your fact finding is not sufficient, then your DFD will also can be insufficient DFD, or meaning that you cannot solve the problem effectively lah. Okay, so please make sure your fact finding is okay, is complete, then you can perform the drawing the DFD. Okay, so to draw a DFD set, okay, it has 3 steps altogether. Okay, step 1, you draw a context diagram. Step 2, draw a diagram 0 of DFD, and step 3 to draw the lower level diagrams. Okay, so here are the guidelines for drawing the DFD. Okay, so dia kata kat sini, draw the contact diagram so that it fits to one page. Okay, so one contact diagram for one system must fit in one page only. So tak bolehlah bermuka-muka. Okay, so you have to draw in one page. And then second, use the name of the information system as the process name in the context diagram. Okay, use the name of information system. The name of the system must be placed in the process of the context diagram. Okay, tengoklah nanti context diagram ni macam mana. Okay, so the process, okay, context diagram only has one process. So the process is must be named with the information system name. Okay, for example, the process name is grading system. Notice that the process name is the name as the system name. Alright. Okay, the third guideline is to use Unix name within each set of symbols. Okay, it is very important to distinguish one process or one symbol's name to another. Okay, please use unique names, okay, in every single symbols that you have. Okay, the fourth guideline is do not cross the line. Okay, you have so many lines of data flow, so please do not cross the lines. Okay, and then provide a unit name and reference number for each process. Okay, if it is needed, please provide a reference number. Alright, and then the last one is obtain as much user input and feedback as possible. Okay, you have to obtain user input, as much user input, okay, or we can say as sufficient as you can, okay, you input from the users to be inserted or to be as a data, input data for the system. Okay, now let's just discuss on the first step of drawing the DFD, that is drawing the context diagram. Okay, so context diagram is a top-level view of our information system. Okay, it only shows the boundaries and the scope of an information system. We can say that context diagram is helicopter. It's a helicopter view of a system. Okay, we see everything only on the top level. Okay, and in context diagram, you cannot show the data store. Okay, because the data store is the internal part of the system. So now you just have to show the top level, okay, or the external part of the system. Okay, here it shows all the rules and regulation in drawing a context diagram, so you can read it by your own. And I will go through to the next slide and showing you how to draw the context diagram. Okay, to draw a context diagram, okay, you have to start by placing a single process symbol in the center of the page. Okay, so here in this example, the process symbol is named as the grading system, and it is refers as number 0. Okay, so number 0 is the unit reference for the process lah. Okay, why it is 0? Because this is the name of the system. Okay, it is not a specific process yet. Okay, but it must be placed here, so we refer it as a process 0. Okay, and the name of the process is the system name. Okay, grading system. Okay, next you have to place the system entities around the perimeter of the page. Okay, so you place all of the external entities around the grading system process, and then you use the data flow, okay, the data flow symbol to connect all of the entities to the central process. So how are you going to know which entity will be connected to which data flow? Okay, so here it is very important to refer to your system requirement document. So your fact finding must be accurate, your system requirement must be complete, and then you can draw an accurate context diagram. As you can see here, there is no data store symbol. Okay, because data store symbol is not included in context diagram. Okay, please remember context diagram is only the overview or the helicopter view of a system. Okay, so the data store is the internal view of a system. Okay, so that is why the data store is not shown here in context diagram. Okay, here is another example of a context diagram with more external entities and more data flows. Okay, this is the context diagram for system manufacturing system. Okay, so it needs more than 10 external entities, and also it has lots of data flow. So you can study from this diagram, this context diagram, where these context diagrams obeys all of the rules that is stated previously. Okay, it has no overlapping lines. All of the symbols are in one page. There is only one center process, and the center process is named as the system name. There is no data stores symbols here because it is not required. And all of the symbols name are written in capital letter. Okay. And you also can see where all of the names in entity, okay, then the entities names are named with the noun. And the data flow name is also named as the noun together with the adjective. Okay, now let's move to the second step, that is to draw a diagram 0 DFD. Okay, so the diagram D0 of DFD is an exploded view of a process 0. Okay, meaning that you have to expand the context diagram process. Okay, so before this, you only write the system name on the process that is numbered as 0. Okay, so now in 0 diagram, okay, 0 diagram of DFD, you have to expand the process into exact number of process. For example, you have 3 sub-processes, so you have to list all of, you have to draw all of the 3 processes in the diagram 0 DFD. Okay, all the thing that you have to remember is diagram 0 also repeats all entities and data flows that appear in context diagram, meaning that the number of entities and the number of data flows in context diagram must be the same in diagram 0. If you have 3 entities in context diagram, then you must have 3 entities as well in your diagram 0. If you have 10 data flows in your context diagram, then you must draw 10 data flow in diagram 0 as well. Okay, let's take a look on this example. We have an example for grading system. Okay, so on the left side is the context diagram and the right side is the diagram 0. Okay, so on the left is the diagram, is the context diagram. So you can see that the name of the 0 process is grading system. That is the system name. Okay, so you can see here there is only 3 external entities. Those are student record system, okay, student and also the instructor. And you also can see there is 6 data flow, that is final grade, submitted work, class roster, class work, grading parameters, and also grade report. So the number and all of the particulars of entities and also the data flow is same in the diagram 0. I have marked all of the entities according to the colors. Okay, so student record system in the contact diagram is also known as student record system in the diagram 0 on the right side. Okay, so student also in the green box. Okay, I have marked it in the green box, also known as student in diagram 0, and instructor in the blue box is also known as instructor in the diagram 0. And there is no additional entity, okay, in the diagram 0. And you also can see the numbers and also the names of all of the data flow. Okay, so for example, data flow for final grade and the class roster is also appeared in the diagram 0. Okay, and the source of final grade and class roster also come from the same source. Okay, in the contact diagram, okay, final grade and class roster come from student record system entity, and you can see in the diagram 0 on the right side, the class roster and also the final grade came from student record system as well. So the only difference of context diagram and the diagram 0 is the number of process. Okay, so the contact diagram only has one process, that is grading system, and it is numbered as 0. So now in the diagram 0, the grading system process is expanded into particular and unique process. I have marked all of the process, okay, with the orange lines, okay, where the grading system is a very general name of a system. Okay, it is general because it's the name of the system. So what are the process that need to be done in the grading system? So in this example, there are 4 sub process that need to be carried out in the grading system. So the first process is to establish the grade book. Okay, so it is numbered as process number 1, and then process number 2 is to assign final grade. Okay, that is process number 2, and then process number 3 is to grade the student work, and the last process is to produce the grade report. You also can see here there is one data store, that is D1 grade book. Okay, so the grade book data store is used to store the class grade book, to store the final grade, to store also the student grade, and it can produce the class detail and the grading detail to the system. So the important thing that you have to remember in drawing the diagram 0 is to make sure that the numbers of entity and the numbers of data flow in context diagram and in diagram 0 is the same. Okay, if there is 3 external entity in contact diagram, then there also must be 3 external entity in diagram 0. Okay, so you have to make sure the numbers are the same. If the numbers are not the same and the name also different, then if it is in test, your mark will be deducted lah. And if it is in the real world situation, then your diagram 0 is a totally wrong diagram 0. Okay, so the last step in drawing the DFD is to draw the lower level diagrams. Okay, so lower level diagram is needed in a complicated system. Because in a complicated system, there are lots and lots of processes that need to be narrowed down. And as a system analyst, you have to identify all of these sub-processes, all of these small sub-processes, so that your system can solve every single problem that aroused. So to do this, you have to use the leveling and balancing techniques. So leveling is the process of drawing a series of increasingly detailed diagram. Okay, for example, if you have a verify order here, okay, 1.1 is verify order. So if there is a sub process of verifying order, okay, for example, in verifying order you need to calculate something in order to verify the order. So you have to draw another detailed diagram of that calculation process. And you have to do this, okay, you have to detail down all of the process until all the functional primitives are identified, until all of the functions, all of the process are identified. Balancing is another task that you have to do, is where you have to maintain the consistency of input and output of the DFD. Okay, where you have to maintain the number of input, the number of output, where you have to balance the numbers with the initial numbers, okay, from the context diagram and the higher level of DFD, or as stated in diagram 0. Okay, so that's all for this video. Okay, so the next two subchapters I will cover in the next video or during the live Google Meet session. Okay, so until then, thank you so much and see you in the next video. Assalamualaikum. Bye-bye.